then ask you your destination in Ghana.
I hope they'll carry me direct.
So like this, you don't something.
If you don't finish, you don't finish, I'm carry ass. If you don't finish.
Big TV, so what next?
Beg no tell him drive
Every shot,
and
drink water. I don't know the shots. Calm down now.
Hey, this man here this thing now.
Nick, you know, give it to
Don't do the shots first.
You won't do what that
I won't drink water first.
What you do when you want to do that?
No, sister, now yesterday I passed out today. I don't move.
Did something now for myself.
I never knew you lived today.
No, I knew I lived.
When I saw your face, I just thought
I knew
Good morning, everyone.
I knew I was going to. No, I'm not still.
You're welcome to today's class.
That place, the place is not bad. The food costs are actually cheaper than
Sorry, I'm making a journey.
that place. Food costs
I'm supposed to be around,
cheaper than Bayelsa.
but I'm
Like in
traveling.
Bayelsa, I go home.
But I don't want us to waste the period. That is why I want us to have an online class. So, but then when I come back,
they don't even reflect on
we are going to do a physical class where I do a comprehensive review and summary of whatever we are going to discuss here this morning.
The first time you saw
And
me,
I
don't
hope
forget we just coming from camp.
all the departments are on ground.
Yes, sir.
I hope all the departments are on ground.
I was just coming from camp.
Please, if you-
don't forget to 3 weeks in camp that time.
If network is disturbing, kindly go to Convocation Arena. I believe that you'll be able to access network over there. The last time I came, we were having a discussion on blood physiology, and while the lecture was going on, my head of department and displaced me.
My own is that it's fast. That's just it.
Today,
Like, I don't like this one. I have a choice.
I'm actually making a journey, like I said, and I don't want us to miss this period
Why?
because time is very precious. Time is very precious.
I had to wake up
So,
27
Please, let's have our class.
From there to years up to my phone hour ride.
I'm already in that.
So today we are going to continue our discussion on
I had to
blood.
start coming.
We'll continue our discussion on blood.
I don't really know.
In the last class, I told you what blood is.
I moved.
I told you that we usually have 4 types of tissues.
Second boss, yes, 9.
We usually have 4 types of tissues. We have the muscle tissues. We have the epithelial tissues. We have connective tissues, right? Muscle tissues, epithelial tissues, connective tissues, and then we have nervous tissues. I repeat, we have muscle tissues, epithelial tissues, connective tissues, and nervous tissues. And then I told you that blood is a connective tissue in fluid form. But blood is a connective tissue in fluid form. Right? Blood is a connective tissue in fluid form. And I told you that blood is a fluid of life. It's a fluid of life because it contains lots of nutritive substances that nourishes the body, nourishes the tissues of the body, such as amino acid, glucose, lipids, and the rest of them. So we call it the fluid of life because it provides nourishment to the tissues of the body, the cells, the tissues, and the organs of the body. I also said that blood is a fluid of growth. It is a fluid of growth because it contains lots of hormones. It contains lots of hormones, enzymes, and other substances that are implicated in the growth of the body. A good example is the growth hormone. Growth hormone. I also said that blood is a fluid of health. Blood is a fluid of health. Blood is a fluid of health because it provides, it helps to defend the body. It helps to defend the body against pathogenic organisms, right? That are unfriendly to the body. Pathogenic organisms that attack the body. Pathogenic organisms like bacteria, viruses, and fungi that are enemies to the body. So it is a fluid of defense. It provides defense and protection for the body. Now, let's recap on our discussion about the properties of blood. The properties of blood. The first thing we mentioned was the color of blood. And I was able to tell you that blood is red in color. Blood is red in color. Remember, I said that arterial blood is scarlet red in nature. Arterial blood is scarlet red in nature. And I also mentioned that venous blood is purple red in nature, right? Arterial blood is scarlet red in nature. Venous blood is purple red in nature. So in other words, blood is red in color. And also we talked about the volume of blood. And I said that a normal adult has the volume of blood in a normal adult is 5 liters. 5 liters. And that value is less in children. The value is less in children. Children usually have 450 ml of blood, right? But adults usually have 5 liters of blood, right? Children has 450 ml of blood. But when once a child begins to develop and progresses into puberty, right, the volume changes. It increases and gets to 5 liters. Also, there is a discrepancy between the volume of blood of of male and female, right? There's a difference in sex, right? Male usually have 5 liters. Female usually have 4.5 liters. And of course, you know the difference. Like I mentioned earlier on, the difference is that, women, though it is very, very insignificant and negligible, but then it's important to know that female usually have less amount of blood. Female usually have less amount of blood because of menstruation, because of their monthly flow, right? Because of their monthly flow. So female has less amount of blood, right? Adults have 5 liters of blood, male have 5 liters, female have 4.5 liters, children has 450 ml. As they progress in age, then the volume increases, the volume of blood increases. Then another reason why female usually have less amount of blood is because normally in a normal typical the total body water or body fluid of a normal individual is 60%, right? Is 60%, solid is 40%, right? And now the the total body water is about 42 liters. 42 liters, right? 42 liters. Now that value is more in male and less in female. And the reason why it is less in female is because of the presence of adipose tissues. Adipose tissues in female. Female has lots of adipose tissue. Adipose tissue means fats, right? It means fats, lipids. Female usually have more of fats or adipose tissues. And that is why they have less amount of fluid. They have less amount of fluid. And of course, you know that the fluid includes both plasma and the interstitial fluid, and of course the interstitial fluid, right? Of which blood is part of the extracellular fluid, which is plasma, right? Right? So female usually have less amount of blood. Then we also talked about the reactivity of blood. We talked about the reactivity of blood, and we mentioned that blood is slightly alkaline in nature, and blood has a pH. It has a pH of 7.4. That is to say that it is slightly alkaline in nature. And I mentioned that a slight deviation from that value will cause a problem. For instance, if you go down from that value, like let's say you have something like 6 point something, that is tending towards acidosis, right? But when you go above that value, you have something that is called alkalosis. If you go down from that value, you have acidosis. You go up above that value, you have alkalosis, which is not good for the body, right? Then we also talk about the specific gravity of blood. I mentioned that the specific gravity of whole blood is between 1.052 to 1.092, right? No, sorry, 1.052 to 1.061. Then I mentioned that the specific gravity of blood cells, is between 1.092 to 1.101. Then the specific gravity of plasma, is between 1.022 to 1.026. Let me take it again. The specific gravity of whole blood, is between 1.052 to 1.061. The specific gravity of blood cell, when I say blood cell, I'm talking about the erythrocytes, the leukocytes, and the thrombocytes, or what we call the megakaryocytes. All of them put together, the specific gravity of blood cells is between 1.092 to 1.101. And then the specific gravity of plasma is between 1.022 to 1.026. Right? All right. Then we talked about the viscosity of blood. And we said that blood is 5 times more viscous than water. Blood is 5 times more viscous than water. The reason is because, don't worry, as the lecture progresses, you will know the reason, but then let me mention the reason. The reason is because of the presence of plasma proteins, like the fibrinogens and the globulins and the albumins and the rest of them. You know, these plasma proteins, especially fibrinogen, tend to increase what we call redox formation. That is to say that they tend to bring about redox formation. They allow blood to pile up like coins. And so because of that, it increases the viscosity of blood and also increases the sedimentation rate, the erythrocyte sedimentation rate of blood. All right, let's continue. We've talked about the properties. Now let's talk about the composition of blood. the composition of blood. In our last class, we talked about the composition of blood, and we mentioned that blood is composed of solid. It consists of solid and water. Consists of solid and water, and of course, you know that the water is the plasma component of blood. The water is the plasma component of blood. Now, the solid is actually made up of. It comprises of cells, blood cells, which, like I mentioned earlier on, they are the red blood cells. Of course, the red blood cells are known as the erythrocytes. The white blood cells, which are known as the leukocytes, and then the platelets, which are known as the thrombocytes or the megakaryocytes. So these three components actually make up the solid component of blood, right? And of course, they are called formed elements. So we can say that blood consists of formed elements and plasma. Blood consists of formed elements and plasma. The formed elements are the erythrocytes, the leukocytes, and the thrombocytes. And then, of course, we'll talk about plasma. You know that plasma is a straw-colored liquid, right? It is yellowish in nature. And of course, plasma comprises of a solid component, and it also has liquid, right? Now, plasma consists of 92 to 93% of liquid. 92 to 93% of liquid. I repeat, plasma comprises of 92 to 93% of liquid and 9 to 8% of blood. I take it again. Plasma, the composition of plasma is 92 to 93% liquid, and then and then 8 to 9% of solid, right? So we are going to talk about the solid components of plasma. Now, the solid component of plasma consists of organic and inorganic solid, right? Organic and inorganic solid components, and then we also have gases. The number of gases is very negligible, very negligible, right? The amount of gases is very negligible, and of course the gases that we have are nitrogen, oxygen, right? Basically nitrogen and oxygen, right? Even CO2 is also present, right? But they are very negligible, very negligible. Oxygen, nitrogen, hydrogen, right? Carbon dioxide, they are all very negligible. Now let's talk about the solid components. For the solid components, we have organic and inorganic solid components. Let's talk about the organic components. Now, for the organic components, the first component that we have is the albumin. Plasma proteins. Yeah, the first components are the plasma proteins, right? Now, the plasma proteins are 3 in number. Plasma proteins are 3 in number. Number 1 is we have the albumin. We call it serum albumin. The second one is serum globulin, right? And the third one is fibrinogen. Serum albumin, serum globulin, and fibrinogen. Now, globulin is divided. Globulin has 3 types. We have 3 types of globulin. We have alpha globulin, beta globulin, and gamma globulin. They all have their respective functions. So, but basically, you should know that we have 3 types of plasma proteins. There's serum. We have serum albumin, serum globulin, and we have fibrinogen. Then the globulin has three types. We have alpha globulin, beta globulin, and gamma globulin. That is that. Then plasma also contains carbohydrates, and of course, like I mentioned earlier on, the carbohydrates is glucose. It also has proteins. It consists of proteins as well. The proteins are amino acids. Amino acids. It also has fats. Fats are triglycerides, right? Cholesterol and phospholipids. Phospholipids. Then it also has some internal substances like hormones. It has hormones, and then it also has enzymes. Enzymes like lipase, carbonic anhydrase. We have acid phosphatase. We have alkaline phosphatase. We have esterase, right? We have lipase. We have transaminase, right? I repeat, let me mention them again. For the enzymes, we have lipase, right? We have lipase. We have transaminase. We have amylase. We have carbonic anhydrase. We have acid phosphatase. We have alkaline phosphatase, and the rest of them. Then we also have non-nitrogenous substances. We also have non-nitrogenous substances like ammonia. We have creatine. We have creatinine. We have ammonia. We have creatine. We have creatinine. We have xanthine. We have hypoxanthine. We have uric acid, and then we have urea. They are all nitrogenous, non-proteinous nitrogenous substances. Right. Now, I also mentioned that part of the solid component of plasma include inorganic components, inorganic solids like our electrolytes, the various electrolytes that we have, such as sodium, potassium, calcium, magnesium, sulfates, name it, you know them, right? All right. So let me repeat it again. Let me take it again so that you grab the concept. Now, I said that plasma has a solid component and also has a liquid component. Plasma has solid components and also has liquid components. And I said that the liquid component consists of plasma has 92 to 93% of liquid, and 8 to 9% of solid. And then it also has gases, which, like I mentioned earlier, the amount is negligible. I mentioned the gases, which are hydrogen, oxygen, nitrogen, and even carbon dioxide, right? Even carbon dioxide. Now, for the solid components, we have organic and inorganic solid, right? I mentioned the inorganic solids are the electrolytes like sodium, potassium, magnesium, sulfates. You know them. Then the organic solids are, the first one I mentioned was plasma protein, which are 3: serum albumin, serum globulin, and fibrinogen. You don't call it serum fibrinogen. You just call it fibrinogen. But albumin is called serum albumin. We have serum globulin and fibrinogen, right? And fibrinogen. The reason why we don't call fibrinogen serum fibrinogen is because fibrinogen is not present in the serum. During hemostasis, fibrinogen is converted to fibrin, right? Fibrinogen is converted to fibrin, and it forms a mesh-like structure, right? And then when that happens, a liquid component of the clots will ooze out, and that liquid component is called serum. Now, if you look at serum, you observe that we have albumin in serum, we have globulin in serum, but fibrinogen is not present, and that is why we call it serum albumin and serum globulin, right? But we don't call, so that's why we call albumin serum albumin and we call globulin serum globulin, but we don't call fibrinogen serum fibrinogen because it is not present in the serum. All right. Then I also mentioned that we have carbohydrates as part of the component of the organic components of plasma, and of course, like I mentioned earlier on, the carbohydrates that is present is glucose. Then we also have proteins like amino acids. We have fats like triglycerides, cholesterol, and then we also have phospholipids. Then we have non-nitrogenous compounds like ammonia. We have ammonia. We have creatine, xanthine, hypoxanthine, uric acid, urea, right? Then we also have enzymes like lipase, amylase, transaminase, carbonic anhydrase, and the rest of them. I've mentioned them. All right. Okay, so now let's talk about the functions of blood. The first function of blood that I'll mention is that blood is it has a nutritive function. Blood has a nutritive function. Now, like we mentioned earlier on, that blood contains substances like protein, lipids, and fats, right? All these substances are nutritive substances. Glucose is nutritive in nature. Amino acids are the building block of our tissues and all that. They are nutritive in nature, right? And of course, fats, triglycerides, cholesterol, and all that are nutritive in nature. They help to nourish the body. And they also help to enhance the function of the body. Without these things, we cannot survive, right? So they tend to enhance our survival and nourishment. The next function of blood is that blood has a defense function. It has a defense function because of the presence of white blood cells, right? And you know that we have two types of white blood cells. We have the granulocytes and we have the white blood cells, right? And then we have the leukocytes, right? The white blood cell is divided into two: the granulocytes and the agranulocytes, right? The agranulocytes are the neutrophils, the eosinophils, and the basophils, right? And then we have the agranulocytes, which are the lymphocytes and the monocytes. Now, the neutrophils and the monocytes are implicated in the defense of the body against bacteria. In other words, they help to protect the body by what we call phagocytosis. That is to say, they engulf bacteria and destroy them, right? They engulf bacteria and destroy them. Now, monocytes and basophils are implicated in they have a parasitic action, right? They destroy parasites in the body. Then particularly basophil is implicated in hypersensitivity reaction, right? The lymphocytes are very, very important in antibody reaction. That is to say that they are important in immune response. They are implicated in immune response. That is to say that they are important in antibody reaction as well, right? Then you know that we also we talked about plasma protein. One of the components of plasma protein is globulin, and there's a particular type of globulin, that is gamma globulin, which is known as immunoglobulin. And of course, you know that immunoglobulin is also implicated in antibody reaction. In other words, it's implicated in immune response. It is implicated in immune response, right? So the first thing I mentioned is that blood has a nutritive function. The second one is that it has a defense function. The third one is that blood has a storage function, right? It has a storage function. Lots of substances are present in the blood which are needed by the body, right? So blood actually stores these substances, and then when needed, they are released from blood. They are released from blood. Blood has liquids. When needed, it is released. Blood has proteins. When needed, they are released. Blood has amino acids. When they are needed, they are released, right? And this concept is actually important during starvation. It is important during starvation. Now, another important function of blood is that blood acts as a buffer. It has a buffer function. It acts as a buffer. Now, the plasma proteins and hemoglobins that are components of blood are implicated in the buffer actions of blood. When we talk about buffer is a substance that removes hydrogen. It has affinity for hydrogen. So hemoglobin and plasma proteins actually have affinity, especially the albumin, serum albumin. They have affinity for hydrogen. They remove hydrogen from the blood and prevent acidosis. They prevent acidosis from taking place. Blood is also important in, apart from the acid-base component, it is important in water balance. It regulates water balance, right? Blood also regulates water balance of the blood. So I've mentioned nutritive function, defense function, storage function. It regulates acid-base balance. It regulates the water content. It regulates the water content of the body, right? It regulates the water content of the blood body and all that. All right. Now, let's talk about plasma. Let's talk about plasma. Plasma is a straw-colored liquid. I repeat, plasma. Plasma is a straw-colored liquid, right? Plasma is a straw-colored liquid that contains the plasma proteins, right? Now, the various plasma proteins that we have, which I've mentioned earlier on, are serum albumin, serum globulin, and fibrinogen, right? We have serum albumin, serum globulin, and we have fibrinogen, right? So the plasma proteins are very important. They are the albumin, globulin, and the fibrinogen. Albumin is called serum albumin. Globulin is called serum globulin. Fibrinogen is just fibrinogen. Now, when you remove blood from the vessel and you put it in a container, right? A container that does not have anticoagulants, you observe that after 45 minutes, right, the blood will clot, hemostasis will take place, and then during that process, fibrinogen will be converted to fibrin, and then a straw-colored liquid will ooze out of the blood. That straw-colored liquid is called serum. The straw-colored liquid is called serum. And like I mentioned earlier on, serum consists of two plasma proteins, which are serum albumin and serum globulin, but does not have fibrinogen. So serum is plasma protein. No, serum is plasma minus fibrinogen. I repeat, serum is plasma minus fibrinogen, right? Serum is plasma minus fibrinogen. Plasma contains all the plasma proteins, right? It contains all the plasma protein, but serum contains albumin, globulin, and fibrinogen. And like I mentioned earlier on, that globulin has three types. We have alpha globulin, beta globulin, and gamma globulin. They have their respective functions. which I will mention as the lecture progresses. Now, there is what we call albumin globulin ratio. Albumin globulin ratio. It is a very, very important or significant diagnostic tool that is important clinically, right? Albumin globulin ratio. It is an indicator for certain renal and liver diseases. I repeat, albumin globulin ratio is important clinically because it is a very important indicator for some renal diseases, right? Such as nephrotic syndrome, and some other hepatic diseases. So we call it albumin globulin ratio, and the ratio is usually 2:1. The ratio is usually 2:1. Now let's talk about the properties of plasma proteins. Properties of plasma protein. The first property I'll talk about the molecular weight. I'll talk about the molecular weight. Sorry about that. Sorry about that. Sorry for the interruption. Now I'll talk about the first thing I'll talk about is the molecular weight of plasma protein. Now, albumin has a molecular weight of about 69,000. It has a molecular weight of about 69,000, right? Globulin has a molecular weight of 250,000. Globulin has a molecular weight of 250,000. And then fibrinogen has a molecular weight of 400,000. So the molecular weight of fibrinogen is times 2. Is more than the two other plasma proteins combined. The molecular weight of fibrinogen is more than the molecular weight of albumin and globulin combined, right? So it has the molecular weight of fibrinogen is more than other plasma proteins. Let me repeat it again. The molecular weight of albumin is about 59,000. The molecular weight of globulin, sorry about that. The molecular weight of globulin is about 250,000. The molecular weight of fibrinogen is 400,000, which is more than albumin and globulin combined. Now, the next thing I will talk about is the oncotic property of plasma protein, right? When we talk about oncotic property, we are talking about when we talk about oncotic property, we are simply talking about oncotic pressure. We are talking about oncotic pressure, right? Now, plasma proteins usually exert oncotic pressure, right? Plasma proteins usually exert oncotic pressure. And what is oncotic pressure? What is oncotic pressure? Oncotic pressure is simply known as colloidal osmotic pressure. It is simply known as colloidal osmotic pressure, right? And this is the pressure that helps to keep it does not allow, it helps to remove excess fluid. It removes, no, sorry, this pressure helps it helps to maintain our what we call hydrostatic pressure. That is to say that it drags water, it drags water or attracts water from the interstitial fluid, right? across and moves this water across the what we call the capillary membrane via osmosis. Via osmosis, I repeat, the oncotic pressure, oncotic osmotic pressure, what we call colloidal osmotic pressure, is the pressure that actually attracts water. It attracts water from the interstitial fluid, right? It attracts water from the interstitial fluid into plasma across the capillary membrane, right? Across the capillary membrane by osmosis. So it does not allow fluid to remain in the interstitial tissues or spaces. Now, of course, you know that if we have excess fluid in the interstitial spaces, that will result to edema, right? It will cause edema, right? So plasma proteins are very much important and implicated in oncotic pressure, or what we call colloidal osmotic pressure. Colloidal osmotic pressure, right? Another thing is that okay, let's talk about the specific gravity of plasma. Like we mentioned earlier on, the specific gravity of plasma is between 1.022 to 1.026. So invariably we can say that the specific gravity of plasma is 1.026. 1.026. All right, 1.026. Now let's talk about the functions. Let's talk about the functions of plasma proteins. The first function I will mention, is that plasma protein has a coagulation function. That is to say that it helps to coagulate the blood. Remember, when we mentioned the components of plasma proteins, the types of plasma proteins, we said that consists of albumin, globulin, and fibrinogen. Now, the fibrinogen component of plasma is actually important in the coagulation of blood. It helps to coagulate blood. Fibrinogen is usually converted to what we call fibrin by what we call thromboplastin activator. Thromboplastin activator usually converts fibrinogen. It converts fibrinogen to fibrin, right? And that actually brings about blood coagulation. It brings about blood coagulation. Very important. It brings about blood coagulation. Another important property of plasma protein is I think I've mentioned earlier on, is the oncotic pressure, which is also known as another important function is the the maintenance of osmotic pressure, right? Maintenance of osmotic pressure. Plasma protein, especially albumin and globulin, are important in the maintenance of osmotic pressure, right? Osmotic pressure. And the osmotic pressure is usually called oncotic pressure. If you don't call it oncotic pressure, you call it colloidal osmotic pressure. It is different from hydrostatic pressure. Hydrostatic pressure. It is called colloidal osmotic pressure. Another important function of plasma. Another important function of plasma is that plasma actually has a transport property. It has a transport property. Now, the plasma proteins actually help to transport enzymes and hormones, right? Especially the alpha and the beta globulins. The alpha and the beta globulins are important in the transport of hormones and enzymes in the body, right? Then they are also important. They are also important in the transport. They are not only important in the transport of hormones and enzymes, they are also important in the transport of metals in the body, right? Are you there? I repeat, plasma proteins have a transport function, right? Globulin, right? That is the alpha globulin and the beta globulin are important in the transport of enzymes, not just enzymes but hormones as well, and they are also important in the transport. They are also important in the transport of metals in the blood. They are also important in carrying metals in the blood. Also, plasma protein has a defense function. Plasma protein has a defense function. Plasma protein has a defense function. Now, like I mentioned earlier on, plasma protein consists of albumin, globulin, and fibrinogen. Globulin in particular, like I mentioned earlier on, consists of alpha globulin, beta globulin, and gamma globulin. The gamma globulin is implicated in the defense of the body. Now, gamma globulins are actually known as immunoglobulin, and we have a lot of them. Immunoglobulin I, immunoglobulin A, immunoglobulin G, immunoglobulin E, immunoglobulin M. All these immunoglobulins are actually implicated in the defense of the body, in immunity. They provide immunity for the body, right? They provide immunity for the body. They help to fight against pathogenic organisms. They help to fight against bacteria, viruses, and fungi in the body. Plasma proteins also they are implicated in the acid-base reaction of the body. Acid-base, they are important in maintenance of what they call. They are implicated in the buffer action of the body. The buffer action of the body. That is to say that they help to provide. They remove hydrogen. They remove hydrogen from the blood, right? And when that happens, it helps to prevent acidosis, right? They carry out buffer actions in the blood by removing hydrogen, and by doing that, they prevent acidosis. All right. Then also, it is important to know that they have plasma proteins actually. They enhance erythrocyte sedimentation rates. They enhance erythrocyte sedimentation rates. They enhance erythrocyte sedimentation rates, and also they help to maintain the suspension stability of blood. They help to maintain the suspension stability of blood. They help in promoting redox formation. They help to promote redox formation and all that. All right. So now let's talk about hemopoiesis. Let's talk about hemopoiesis, and by extension, we'll talk about erythropoiesis as well. Now, when we talk about hemopoiesis, we are talking about the process of blood formation, the formation of blood, the development of blood cells, right? Hemopoiesis is the formation of blood, the process that involves the formation and the development of blood and blood cells, right? Now, when we talk about hemopoiesis, you cannot talk about hemopoiesis without talking about what we call the pluripotent hemopoietic stem cells. Pluripotent hemopoietic stem cells. Now, these are actually primitive stem cells that are implicated in the formation of blood cells, such as the erythrocytes, the leukocytes, and the megakaryocytes.
What is it?
Now, sorry for the interruption. Now, pluripotent hematopoietic stem cells will give rise to, there's what we call uncommitted pluripotent hematopoietic stem cells. Now, uncommitted pluripotent hematopoietic stem cells will give rise to committed pluripotent hematopoietic stem cells. Committed pluripotent hematopoietic stem cells will give rise to committed pluripotent hematopoietic stem cells. Now, the committed pluripotent hematopoietic stem cells are the cells that are committed to give rise to the various group of blood cells, right? They are committed to give rise to the various group of blood cells that we have, right? So they can actually produce what we call lymphoid stem cell and myeloid stem cell, right? They can give rise to lymphoid stem cell and myeloid stem cells. Now, the lymphoid stem cells can actually produce what we call lymphocytes. The lymphoid stem cells can produce what is called lymphocyte. And you know that we have two types of lymphocytes. Not just lymphocytes, but also natural killer cells. Natural killer cells. So it produces lymphocytes and natural killer cells. The lymphocytes are the T lymphocytes and the B lymphocytes. The B lymphocytes, of course, are the gamma immunoglobulins, which I've mentioned earlier on, right? Of course, they are the gamma immunoglobulins. Now, the myeloid stem cells is also known as colony-forming blastocytes. If you don't call it colony-forming blastocytes, you also call it myeloid stem cells. This type of cell gives rise to the various colony-forming units of blood. The various colony-forming units of blood, such as colony-forming units erythrocytes, colony-forming units granulocytes and monocytes, and then we have colony-forming units megakaryocytes. I repeat, we have the colony-forming blastocytes, or the myeloid stem cell, gives rise to three types of colony-forming unit cells, which are colony-forming unit erythrocytes, colony-forming units granulocytes and monocytes, and colony-forming units megakaryocytes. The colony-forming units megakaryocytes are responsible for production of megakaryocytes. Megakaryocytes is also known as thrombocytes. If you don't call it thrombocytes, you also call it platelets, right? You can call it platelets. Then we have the colony-forming units megakaryocytes. Granulocytes and monocytes. The colony-forming units granulocytes and monocytes gives rise to the white blood cells. That is, it gives rise to granulocytes and monocytes. And of course, like I mentioned earlier on, the granulocytes are the white blood cells that actually contains granules in their cytoplasm, such as the neutrophils, the eosinophils, and the basophils. And then it also gives rise to monocytes. Monocyte is an agranulocyte. It is along with lymphocytes, both of them are agranulocyte because they do not have granules in their cytoplasm. Now, when we talk about white blood cells, we'll mention that. We'll talk about all those things. But you should know that the myeloid stem cells gives rise to colony-forming unit erythrocyte, colony-forming unit granulocyte and monocyte, colony-forming unit megakaryocyte. The colony-forming unit megakaryocyte gives rise to platelets. The colony-forming unit erythrocyte eventually gives rise to erythrocytes. The colony-forming units granulocyte and monocyte gives rise to neutrophils, eosinophils, basophils, and the monocytes. Right now, let's talk about erythropoiesis. Now, erythropoiesis is known as the process of formation and development of erythrocytes. It is known as the process of formation and development of erythrocytes. Now, like I said, we usually have what we call uncommitted pluripotent hemopoietic stem cells. Uncommitted uncommitted pluripotent hematopoietic stem cells will give rise to committed pluripotent hematopoietic stem cells, which will give rise to the various group of blood cells like the lymphocytes and the colony-forming blastocytes, which is known as the myeloid stem cells. Now, I'm not interested in the lymphocytes. Like I mentioned earlier on, that the lymphocytes eventually form the lymphoid stem cells eventually give rise to lymphocytes, which are the T lymphocyte and the B lymphocytes, and then the natural killer cells. I'm not interested in that one, right? What I'm interested in is the colony-forming blastocytes. The colony-forming blastocytes. Now, the colony-forming blastocytes gives rise to colony-forming unit erythrocytes, colony-forming units granulocytes and monocytes, and colony-forming units colony-forming granulocytes and monocytes. What is colony-forming erythrocytes? Why am I interested in colony-forming erythrocyte? I am interested in colony-forming erythrocyte because it is the colony-forming erythrocyte that gives rise to erythrocytes. That is the red blood cells which we are talking about, right? They are the ones that give rise to erythrocytes, which we are going to talk about as the lecture progresses. Now, the colony-forming units erythrocytes gives rise to the various stages of red blood cells. And what are the stages? The colony-forming unit erythrocytes gives rise to the first cell, the first generation of cell that it gives rise to is what we call the pro-erythrocytes. The pro-erythrocytes. I will talk about the properties of all the stages, right? But let me mention them first. The pro-erythrocytes. Then subsequently, it divides, right? It divides and gives rise to what we call the early nomoblast. If you don't call it early nomoblast, you call it basophilic erythroblast. Basophilic erythroblast. Early nomoblast or basophilic erythroblast. Then we have what we call intermediate erythroblast. Intermediate erythroblast. And then we also have late nomoblast. Then after late nomoblast, we have reticulocytes. After reticulocytes, we now have the normal red blood cell that is produced. Right? Now let me mention the stages again. From colony-forming units erythrocytes, we now have the pro-erythrocytes. From pro-erythrocytes, we will have early nomoblast, which is known as intermediate nomoblast. Intermediate nomoblast is also known as polychromatophile erythroblast. Then the next one is the late nomoblast. Late nomoblast is also known as autochromatic erythroblast. And then we have the reticulocytes. And then finally we have the red blood cell, which enters into the blood circulation. Right. Now let's talk about the individual stages. Right. Let's talk about the individual stages. Right. But before we go into that, let me talk about the various sites of erythrocyte production. The various sites of the production of erythrocyte, or the various sites of erythropoiesis. The first site is what we call stages. The first stage is the hepatic stage, right? No, not the hepatic stage. The first one is called it's not the hepatic stage. At first, during the first trimester, right? During the first trimester, produced by the yolk sac, right? During the first trimester, red blood cell is produced by the yolk sac. So we call that stage the mesenchyme stage. We call that stage the mesenchyme stage. The mesenchyme stage, red blood cells are produced in the first trimester, right, of gestation. Red blood cells are produced, right, by the yolk sac of the mesenchyme. The second stage is the hepatic stage. During this stage, in fact, this stage occurs during the second trimester of gestation, and the red blood cell is produced by the liver, right? In this second stage, the red blood cell is produced by the liver. And also, there are other structures that also produce red blood cell during this stage. But basically, red blood cell is produced by the liver. There are other structures that produce red blood, like the spleen. The spleen also produces red blood cell, and the lymphoid organs also produces red blood cell during this stage. The third stage is known as the myeloid stage. The third stage is known as the myeloid stage. During this stage, red blood cell is produced by the bone marrow. The bone marrow. During this stage, red blood cell is produced by the bone marrow. Right. Now, after birth from 0 to 5 years, or from 0 to 6 years, after birth from 0 to 5 years, after birth from 0 to 5 years, a red blood cell is produced by the bone marrow of all the bones. During this stage, red blood cell is produced by all the bones. That is from 0 to 5 years. Red blood cell is produced by all bones, both membranous and long bones. Now, from 6 years upward, from 6 years to puberty, red blood cell is produced by the bone marrow of long bones and all membranous bones. Long bones and all membranous bones. Then from 20 years and above, red blood cell is produced by the shafts of long bones. The shafts of long bones and all membranous bones. Right? I repeat, from 20 years and above, red blood cell is produced by the shafts of long bones and all membranous bones. When I say membranous bones, I'm talking about bones like the skull, bones like the vertebrae, bones like the iliac bones, right? All these are called membranous bones. You don't call them membranous bones, you call them flat bones, right? Now, still talking about erythropoiesis, like I said, we have different stages. From the colony forming unit erythrocytes, we now have the pro-erythrocytes. From the pro-erythrocytes, we now have the early normoblasts. From the early normoblasts, we have the intermediate normoblasts. From the intermediate normoblasts, we have the late normoblasts. From the late normoblasts, we have the reticulocytes. From the reticulocytes, we have the red blood cell. We have the matured red blood cell. Now, each of them have their various characteristics. Now, I'm talking about the pro-erythroblast. You observe that, just that we are not in a physical class where there is whiteboard. I would have drawn the diagram. When we meet our next class by next week,